All right, so today we are going to be starting our discussion about what is chemistry. Chemistry is the study of matter. Matter is stuff that's all around us, and we're going to learn a little bit more about what is matter and what is not matter. So, matter has three characteristics. They are, it has to have mass, it has to have volume, and it has to be tangible. So to be matter, you have to have mass, you have to have volume, and you have to be tangible. So we'll give you guys a little bit more detail on what those mean. All right. So mass. What mass is it's the amount of matter. Okay, so it's an amount. It's not weight. Okay, there's a difference between mass and weight. Weight is what we talk about being like pounds on Earth, right? But you're a different weight on Earth than you are, say, on the moon. Okay, so an astronaut might weigh 150 pounds on Earth, but then they go up to the moon, and because there's less gravity, they might weigh only 135 or 140. Okay, so weight has to do with gravity, whereas mass has to do with how much stuff is there, the amount of stuff, okay? I'm the same amount of person here and on the moon. So that's what matter is. We measure it in a unit called grams, and we use a lowercase g to represent that. Okay, so that's mass. Volume is the measurement of how much space is being taken up. So how much space does something take up? Right? And we measure that in liters, like a 2-liter soda container, okay? It measures the volume of the soda, all right? So you have to have volume and mass. The third thing that you have to do is be tangible. So this is a new word for you guys. It just means you have to be able to touch it, all right? So something that's tangible, you have to be able to touch. So something that is not matter because it's not tangible is an idea, right? Ideas, you can't touch an idea, all right? So it's not tangible. Similarly, the idea of maybe like happiness or sadness, you can't touch sadness. Sadness doesn't have any mass. It doesn't have any volume. You can't touch it, so it's not matter, right? An example of something that is matter would be like your pencil. A pencil has mass, all right, because it has an amount of stuff, right? It has volume because it takes up space, and you can touch a pencil. You're probably writing with one right now, hopefully, all your notes, all right? So that's matter. Now matter, once we've decided something's matter, it separates down into two categories. They're pure substances and mixtures, okay? So if something has a constant composition, it's all the same stuff, it's called a pure substance, all right? It's a pure substance. And there are two categories with pure substances: elements, like on the periodic table, and then compounds, okay? Compounds are going to be made up of your elements. So let's define elements first. So an element cannot be separated by physical or chemical means. Elements cannot be separated physically or chemically. An example of an element that you guys are probably pretty familiar with is aluminum, right, from aluminum foil. Or another example is iron, okay? Those are, you might have a sheet of aluminum foil, okay, and you can rip it, but there's still just aluminum atoms lined up in order, okay? That's what an element is. It's a pure substance. On the other hand, we've got compounds. Compounds are two or more elements that are chemically combined. An example is water. So if you look at that picture, I've got a kind of goofy, silly picture of what water looks like. Sometimes we refer to water as H2O. So that means there's two hydrogens and one oxygen that make up water. And in a glass of water, you have a whole bunch of H2O molecules, okay? So if you look at this little picture here, This is your oxygen, is the red, and then the little purple guys are your hydrogens. All right? So that's a compound. So we've got elements and compounds being pure substances. But if you're not a pure substance, you're a different type of matter. Okay? That means that you're something that's made up of pure substances, okay? So if you're made up of elements and you're made up of compounds, of a combination of both of them, it's called a mixture. Okay, so you guys probably heard this before. You're a mixture if you're made up of elements and compounds, all right? There's two types of mixtures. There's homogeneous and there's heterogeneous. If you guys look at those root words, homo means the same, hetero means different, okay? So it's homogeneous and heterogeneous. So if we look, we look back in there at our homogeneous mixture, you see Kool-Aid. It's a mixture of water, and it's a mixture of the Kool-Aid powder, which is essentially sugar. So you've got sugar dissolved in water. So that's a mixture. And it looks the same throughout. So a homogeneous mixture looks the same throughout. Over here, our heterogeneous mixture does not look the same throughout, okay? It looks different throughout. An example of a heterogeneous mixture is the salad over here, because if you take a slice of that mixture from any angle, it's not going to look the same. It's going to look different. So something like a meat lover's pizza pie, okay? That is also going to be a heterogeneous mixture, because you're not going to have your sausage or your pepperoni or your bacon all in exactly evened out spaces, right? It's all going to be, maybe you have, one piece that's got 3 pieces of pepperoni and another piece that's got, a lot of something else. Okay, so that's your heterogeneous mixture. All right, so I want to take us all the way out, and we're going to look at our mixtures. Again, our review are homogeneous and heterogeneous. We've got our pure substances, which are elements and compounds, and both pure substances and mixtures make up matter. All right? All right, let's bring us all the way out, and that's it for now. All right, thank you.